Okay, so firstly, next week. Okay, well, so Mr. Very student had been very clarified. So next week, Mr. Knox will guide you through the project. Okay, so the project is very simple. It's just make sure that you understand the materials and you apply it. I mean, basically, the assessment in this course, right? The midterm, the quiz, the final exams, they are all paper-based. And with paper-based, we only can ask you to interpret the result of the data. The project going to be the time for you to finish with data. So you got your own data, you run the regression, you got the result, and you really see the problem that may arise with your data, for example, and you deal with those problems. So the project is going to be the chance for you to finish with the data and finish with the software and the package, for example. Okay, so don't worry, Mr. Knox will guide you through all of the project here. And so he's gonna explain all the requirements as well as the steps to carry out the project starting from next week. Okay, so let's see about project. Okay, so that's it, right? So now we're gonna move to chapter 10. Basically, from chapter 1 to chapter 9, we talk with this cross-sectional data. Okay, so you already know that we got 3 different types of data: cross-sectional data, time series data, and panel data. Okay, so cross-sectional, we stand at a point in time, and then we study different observations. So today, at this time, I'm studying what are the factors that affect wage. So I look at random people, right? I collect a random observation, for example, and then I see what are the factors that affect wage. So that's the cross-sectional. Now we look at time series. Basically, right, from chapter 10 to chapter 67 something, these are all about time series. Chapter 10 here, right? We do not basically look at time series in this course. This course basically focus only on cross-sectionals. And this is the link of cross-sectional and time series. I want to show you that why we may not use the OLS in time series data. We confidently use OLS with cross-sectional data, and even with panel data, we can use like the pooled OLS model, for example. But the OLS model may not be a good model to use for time series, because we're going to see that there's not a lot of violation of the classical regression assumption with time when we use time series. Right. So, and that's why in time series data, and then they develop other models like the autoregressive model, the moving average model, co-integration models. So those are the models developed to study the time series. But fortunately, right, we will not learn those models here. Here in this model, we just compare the assumption under the classical regression models and see how that can be violated if we use time series data, and we stop there. Okay? And we still stop there, right? We're not going into details of the time series data. So, chapter 10, basic regression analysis with time series data. The in time series here, right? These are the nature of time series. Firstly, time order of observations. Temporal ordering of observations. So it's like when I collect data, cross-sectional data, right? So observation 1. Okay, so I got here, right, y1 and x1, right? I got only 2 models, so y equal to beta 0 plus beta 1, x1, and plus an error term, for example. So that's the our model. And then I collect data. So y1, x1 going to be for the first person. And then I got y2, x2 for the second person. And and then I got yn, xn for the n person. Right? So the ordering of this variable is of no importance. I can put y1 first, I put yn first, right? It doesn't make any difference for cross-sectional. However, for time series, it matters. Normally, in time series data, right, you need to put the data here in a timely order. So, for example, I collect data from, say, 2000, right, and then I study from 2000 to 2020, for example. Okay, so I need to order the information this way, right? Okay, I can put it in like a decreasing order or an increasing order. Right, so it can be either in increasing order or decreasing order, but the order here is important. So I can put here 20, 21, 22, for example. Yeah. I cannot put like 20, 21, and then up to back to 13 and then 15, for example. So the ordering of time series data is important. The ordering in cross-section is not important, right? Okay, so the first person, the second, the third, I can separate and put any order that I want. But in time series, it matters. So that's the first thing. The second one, in time series here, right? Normally, you're going to have here serial correlation. Serial correlation. So if I look at this, I have here, right, two equations. The first equation here is I study, the wage, right? The effects of education and wage. So just assume that we got linear regression, very simple one. So beta is 0, and then clearly the 1 education, and plus and then return. So very simple, right? Just wage, number wage. So now, right, we got the assumption here, right? So the error term here is not zero correlated. So, right, epsilon of EA and EI and EJ gonna be equal to 0. The error terms I got here, right? I read the regression here, right? I got A1 for the first observation. I'm gonna have here, right? A2 here for the second observation, right? And these error terms here, they are uncorrelated. So there's no correlation among the error terms. The covariance, the correlation between among the error terms, gonna be equal to 0. So the error term of different people, right, will not be correlated. But then if you look at time series, we did have different people, but we have different years, right? So the error term, I may study here, right, the relationship between, say, everybody know the fixed equation, right? Unemployment and inflation. Okay, so I've got here inflation, right, and equal to beta 0 plus beta 1, and then unemployment, and plus another term. Okay, so the other term here, right, I got the first other term, going to be the other term, say, of 2020, right? And maybe the second other term here, right, going to be the other term of 2019, right? And these other terms, they may be correlated. Right? They may be correlated because it's the same inflation and GDP, but of different years. So in time series here, right, you got the problem here of zero correlations. GDP of the previous years can affect the GDP of this year. Inflation of the previous years can affect the inflation this year. Right? It's in cross-sectional, right? Your score may not affect the other people's score. No. But in time series, you got that problem. So a variable here can be affected by their own past value. And we call that zero correlation. Zero correlation. So that's also another correlation, right? Here in cross-sectional, we assume, no zero correlation or no autocorrelation. So this is right, no autocorrelation here. No autocorrelation, but that problem, right, prevailed in time series. Time series, you got serial correlation. You got serial correlation. And it's also here, right, in cross-sectional data, right, and we assume, okay, the observations here, right, we got one assumption here related to the data. So the data here, right, is not random. In cross-sectional, data is not random. But in time series here, right, the time series here I model as random variable. A random variable, and the sample here is the one realized part of the time series. So what does that mean by that? If we collect information like like feathers affect wage, and then I'm gonna get samples. So I'm gonna get sample from people in Ho Chi Minh City, and got sample from Hanoi, for example. So I got sample in Vietnam, I got lots of many samples. But then if I study what are the feathers that affect the stock price of Vinamilk. Okay, so my samples here, I'm going to collect the historical data of Vinamilk from 2010 until now. Right, so I've got here a sample of 10 years data. And that 10 years data here is one real-life task in the overall time series, the possible part of Vinamilk. So we can think of the whole population of Vinamilk gonna be the stock return of Vinamilk in the past as well as in the future. And the sample is one short part in that whole part of Vinamilk stock returns. Okay, so that is the sample here. The sample. It's not kind of like a random sampling, right? In cross-sectional, we say we use random sampling. But in time series, we cannot say, okay, I want to pick this year's, I want to pick another year's. No, you cannot do that. You're going to pick a sample consists of many years in the whole life. You're going to have a time series, say, okay, I'm going to pick one data in 2020, and then one data in 2010, and then one data in 2015, and then put in and then run the regression. Right, so in the time series here, right, you cannot have random sampling. The samples here, that's in one part, right, one realized part in the time series here, in the time series. So I'm going to study here into the time sample from, in the past 5 years of data. My sample can be the past 10 years of data. Right, in this research, he studied the failure to affect Vinamilk stock, and he used data from say 2010 up to 2015, because his paper was published in 2016, for example. Now I want to study the same thing, but now because it's 2021 already, right? So I can have data from 2000 up to 2020, for example. Okay, so you're gonna see, right? Okay, so this is the data here, right, related to the U.S. inflation and unemployment. So these are some of two series. Okay, so it has to be order, right? It can be put in decreasing order or increasing order. So this is for increasing order, right? You've got the older years first and then increasing. But sometimes series, you can put it the other way around. So you can put the late years up there and then going down. Going down. And then you've got the inflation rate and the unemployment rate. Okay, so the time series here, right? Now with time series. Okay, this is how you write the cross-sectional, but with the time series, so we're going to write something like this. Okay, so we're going to write here, right? Y and then T. So the observation at time T, right, equal to beta 0 plus beta 1 x1t, right, plus beta 2 2 x2t, for example, plus another term. Okay, so you got the little t here. You got the little t. And here, right, we got here. First we look at the static model. So in the static model here, right, you got only IT here, right, is affected by the current xt. Right, so YT is affected by the current xt. So you got here, right, inflation at time t, and it's split by unemployment at time t. The murder rate at time t is affected by this, right, current commission rate, current employment rate, and then the pressure of the current rate, the population. So we say contemporaneous relationship. Contemporaneous, that means current time. Current time. So that's the static model. The static model. However, in time series, you normally have, if you study the macroeconomics variable, and now you know that the macroeconomic variable, but they have some lag effect. For example, if you want to study the effect of money supply on interest rate, so the government increase money supply on GDP. So it doesn't happen that money supply today and GDP increase today. There may be some time for the monetary policy to take effect. So you're going to study, okay, what is the effect of money supply in the previous quarters that affect the GDP growth in this quarter. Okay? So it's not the money growth in this quarter that affect the GDP in this quarter. But maybe the money supply in the previous quarter affect the GDP in this quarter. And that's the second one here, right? We got here the finite distributed lag models. So in the finite distributed lag model, right, the explanatory variable are allowed to influence the dependent variable with a time lag. So you can study, right, for example, in this example, right, they study the fertility rate, children born, and that's the effect of the tax exemption of the previous years. Or we study, right, the effect of the money supply to GDP growth rate, for example. So the growth rate in money supply affect the GDP growth rate, and we studied that, right? So in previous years, or in previous quarters, for example, in this quarterly data, how that affect the GDP growth in this quarter. Okay, so this model called the finite distributed lag model. The static here, right? In the static, it just explains the contemporaneous here, right? The contemporaneous here. So time t and time t only. But here in the finite distributed lag model, right? So you can have here, right, y, and explain by beta 0 plus beta 1, for example. So x1 at maybe time t, right? And then you may have here, right, beta 2 x1 times t minus 1. So it can have both, right, contemporaneous as well as the lag variables here. So only one, right, x1, and then you got here x1 t minus 1, and then maybe t minus 2, t minus 3. So this model here, finance, we didn't learn it here, but then you got like the other progression model, and then they're going to determine how many lags that you should be calculating. Right. So if you're interested in, you can read further chapters. Here we just stop here. So you have that time model here. So now if we use this time model here, right? So if you look at this.
Gửi cho My đi.
Chưa bật lên cái gì.
So in this simple formula, for example, I study, right, the effect of ZT, right, on YT. So I took out only one variable, right? So ZD, right, on YD here, right? But related ZD here, right? I got ZD, the temporal variable, right? ZD minus 1 and ZD minus Q. Okay, so this here, part is really lack, right? So if you interpret, for example, delta S, and delta S here is just the effect of, say, actually this is the sample of money supply, right? So I've got here, right, the growing GDP. So I got here, right, the growing GDP, right, equal to beta 0 plus beta 1, and then I got the growth in money supply, and times T, right? And then I got here beta 2, the growth in money supply, and times T minus 1. And then I got here, right, growth beta 3, the growth in money supply, and times T minus 2, and plus 7. Okay? So this is, I studied the effect of money supply on GDP. Right? So now if we look at beta 1, so beta 1 is just the effect of the current growth in money supply, right? Related to GDP. If you look at beta 2, so that's just shows us the effect of the money supply in the previous year. How that affect the GDP of this year. Right? So beta 1, beta 2, beta 3 here, it just shows the transitory source. So the source in the previous period. But it's not the whole variable, right? Because you got NS here, when it's supply here, when it's supply here, when it's supply here. Okay, so what are the effects of money supply toward GDP? You have to incorporate all of this. If we just look at beta 2, it just shows us the effect of money supply in the previous years toward the GDP this year. Right? Beta 3 just shows the effect of money supply in the previous 2 years related to GDP this year. So that's here, right? Transitory source. Transitory source, right? So the dependent variable will trend temporarily here, right? By this corresponding lag. And then if you want to see, right, how much is this component one here, right? So how much the NS here increase affect that GDP here, right? So you have to put all of these together to be able to study the permanent source of all the lag.
Người cha về đức của họ.
All the lag. So that will include all of that here. So basically, we do not study it here. But basically, all of that delta here, right, normally smaller than before. Okay, and then you got here the coefficient of this. Right. The effect here, right, the coefficient here, right? So the effect, it peaks out at 1 and then it vanishes. Right, so in lag 1, right, this is 0, in lag 1 it's higher. But then you got the effect here, you get it smaller. So in this example, right, you can say, okay, money supply of the previous years can affect the GDP at the highest, right? But then 2 years after, it will affect GDP to 0 and it's smaller. So you get it over time. This is normally the effect of small, right? It's quite high at the beginning, and then it dying down. It dying down. So it's that so here, right? The transitory and then the permanent. But anyway, right here we just have a few look at that only, but we're not going to detail into the model. So now let's see how the time series here violate or can violate the OLS assumption. So remember, under the OLS assumption in cross-sectional, right, we got 6 assumptions. 6 assumptions. Now we will review, right? Assumption 1, linear in parameter. Yeah, that's the, okay. So that assumption will not be violated. Right, real time series, a lot more than time series, and you will still have that linear in parameter. Okay, so that's going to be no problem. Assumption 2, right? No perfect collinearity. Yes, we can have that no perfect collinearity. However, we're going to have a problem later on related to zeros correlation. But no perfect, but in the sample, no independent variable constant, no perfect linear combination of others. Because basically, right, when we run the regressions here, right, and for large data, there is magic to get bigger. And if we can write x1 right in the form of alpha 1 here, right? So basically, the rank of this is not equal to n. So that you cannot get the inverse of the matrix, you cannot get the solution. Okay, so in that case, right, no perfect collinearity. Okay, that's assumption is okay, right? But then we got here, the next one, assumption 3, zero conditional mean. Okay, zero condition means that means the unit term here, right, the expected value of the unit term given on the x here equal to n, and related to the time series, that means the value of explanatory p variables in on periods. It's not today, right? It's on the periods here. So that's going to be a parabolic, right? You got here, right? Right. So the unit term here, right? Given on x here, x to the exterior in the same periods. So that's the exterior, and that's straight one. So on the period here. Right, so if you talk about the weak form, okay, so maybe the unit term of time t will given the exterior is got no relationship with xt. So at this period only, right? But the strict instruction exterior is that okay, that make x here. So make x here stand for the whole line of x. So on the period of x here, on the period of x. And so strict instruction is stronger, right? It's stronger. So now we're going to do a review first, right? And let's see if we go to how that violated the assumption later. So let's say assumption 3. And with assumption 1, 2, or 3, if they are satisfied, and we got here the OLS here, right? They are unbiased. The estimate and the OLS, they are unbiased. Okay, so linear parameter, no perfect collinearity, and then here, right, zero conditional mean. If you got that 3 factors here, right, and you got here unbiased. And then again, right, you got here assumption for homozygosity. Right, if you got that homozygosity, right, normally in the time series, I'm going to show you later, that's it violated as well. Right, but then back to the procedure, right, you got that time series here, homozygosity, no zero correlation, or no autocorrelation, right, and finally here, right, the normal.
Làm sao để ta copy cái hàm nhân mà chẳng gặp được đâu.
Normal, right? Normal again. So remember in our assumption before, right? We got that 6 assumption for the OLS here, right? Assumption 6 to get the inference. From 1 to 3, then make sure that the OLS is unbiased. And then you got 4 and 5, make sure they are best linear unbiased estimate. Right? And then you got assumption 6 here to make sure that yes, we can get inference from the OLS. However, in a time series, these assumptions may be easily violated. And we got this. Okay, so now we're gonna do this one. I'm gonna take a sample here, right? Here in this, we're gonna get here the static equation. So the static equation here, right? right, here you got inflation is a function of unemployment. And that is only at time t, right? At time t. And then you got here, right? Okay, you got the third number observation 49. Adjust the R squared very low. Right, so there's maybe some more variables that have to explain inflation apart from unemployment. And you can think of inflation like money supply, right? Higher money supply, high inflation level, for example. You can think of like income and the oil price shocks, for example. So you got here the supply source inflation, increase in oil prices like inflation. You're gonna have many other things here, right? But anyway, if you just look at this, right, and then you can see, okay, whether that here gonna whether we're gonna compare this right with this classical linear assumption. I will show why the time series can easily violate this. Right? So firstly, right, the form.
That's công thức.
Right? So they are linear in parameter, right? But they may not be a good model because there's gonna be a lot of factors that affect inflation rather than unemployment. Okay, so that's the first observation here, right? So you may omit a lot of variables here. Omit a lot of variables here, so you have more here, right? And then, okay, assumption number 2, perfect collinearity. Basically, for time series, and then you rarely got the case of perfect collinearity. Variables, they move together. Especially macroeconomics variables, they tend to move together. They correlate it, but not to the extent of perfect collinearity. Okay, so that's not a problem in time series, most of the cases. Most of the cases. And then assumption 3, right? The error term here, right? The conditional, the error term here, right? The error term here, the expected value of the error term given out of this unemployment here equal to 0. Equal to 0. And that's easily violated. It is easily violated because, for example, right, you got here unemployment in the previous year, the previous quarter, for example, if you got that increase here, right, so increase here may lead to future demand shocks that will dampen inflation. Okay, and then you also got here, for example, UT plus 1, right? So you got here something like an oil price source in previous quarter increase, right? And then can affect the employment in this period. Okay, so in time